there, my name is Alejandro, and welcome back for day 63 of me doing the Daily LeetCode challenge until I reach 1 year's worth of green contributions here on GitHub. So today's problem is for September 17th, 2024, and let's get straight into it. Okay, today we get a LeetCode easy, problem 884, uncommon words from two sentences. Okay, a sentence is a string of single-spaced separate words where each word consists only of lowercase letters. Okay, single-spaced separated words where each word consists only of okay, sure. A word is uncommon if it appears exactly once in one of the sentences and does not appear in the other sentence. Okay, given two sentences, S1 and S2, return a list of all common words. Return the okay, this is gonna be very easy. All right, so what? So we have this sentence, this okay, this is gonna be very easy. So first of all, what do we call these? S1, comma S2. We can even modify them, but is equal to S1.split based on spaces. We're gonna do S2.split based on spaces, and then we're gonna have we're gonna make this a set, right? So we're gonna have that way we only have unique elements, and then it's like res is equal to an array for word in S1, if word not in S2, res it append word. For word in S2, if word not in S1, res it append word. Return res. Okay, does something like this work? No. Okay. We returned apple and banana. Why is this the case? Okay, so let's print S1, comma S2. I have apple and I have banana. Even though, okay, so this is apple, apple, and banana. So, wait, okay, so maybe I don't know the difference of uncommon. A word uncommon if it appears exactly once in one of the sentences and does not appear in the other sentence. Okay. Okay. So we're not going to do, so essentially all I'm doing is, like for example, apple, I'm considering it because it doesn't happen in S2, but because of the fact that it's a duplicate in S1, we do not want it. So I actually misunderstood the word, the meaning of the word uncommon. So not to worry, we're just going to do this very much more simply. The very first thing we do is we essentially separate things. So here, I'm just going to make it easy for you to follow along with me. The first thing is I split the sentences based on the spaces. So like essentially S1 and S2, I convert it into these arrays, right? An array of all the words inside of it together, right? And essentially, I'm just going to do this. Band is equal to set. For word in S1, we're going to say S1 set and S2 set are equal to just new sets, and we're going to have a band set for word in S1. If word in S1 set band.add word. Otherwise, we're going to say if word not in band okay. Let's do this much more simply. Essentially, okay, we're just gonna have a dictionary, right? D1 and D2 is equal to two new empty dictionaries. For word in S1, D1 of word, we're gonna make these default dicts. Okay. I don't know how to do default dict again. So we'll just do D1 of word is equal to D1.getWord, comma 0 plus 1. For word in S2, we're going to say D2 of word is equal to D2.getWord, comma 0 as a default plus 1. And now we're going to have a band set is equal to set. If we're not in band, Actually, I just need to create the S1 set and S2 set, right? And just keep track of the band elements, right? Okay. Essentially, okay. How do I do this efficiently? Okay, so I can solve the problem very easily. I'm just trying to think of how to do this most efficiently, right? So it's like, instead of O of 3n, why not do O of 2n? I mean, I can also just do it very, yeah. I'm using a lot of extra memory for no reason. Essentially, I can say, equals set, S2 set equals set, D1 of word equals 0. We're gonna have a scene set. Scene equals set for word in S1. Not in scene. S1 set that add word, else okay. I'm just trying to, okay, it's just O of 1 logic that I'm really just being bothered by. There's like a million ways to do this and so on. I'm just bothered by doing it efficiently. And it's like triggering me a little bit. For word in S1, if word not in scene. Okay. I just gotta commit to doing one way instead of like saying like, no, this is too inefficient, no, this is too inefficient, and so on. Okay, but the idea is essentially like prevent duplicates, right? So it's like only get the ones that are unique, but it's like, oh, if I take O of n time to parse that and so on, why take an O of 3n? I'm going to be way more inefficient than all the other guys and so on, and so might as well do this efficiently. I guess my motto is always just try to get it working once and then optimize, right? So you know what, let's just do this the absolute simplest way I can possibly think of, which is forward in S1. We're just going to say d of word equals d dot get word, 0 plus 1. For word in S2, d of word, d1, d2 equals d2 dot get word, 0, plus 1. S1 set equals set of filter d of key equals 1, d dot keys, but this is for d1, and then S2, same thing, but with d2. And in fact, you know what, for now, let's call this S1 and S2, and we had our previous solution here, right? So like this would be the simplest way I could think of making this work, right? So something like this should probably work. Yeah, exactly. And so like submit this and so on. So rule of thumb, get something working and then do something efficient. Okay, and so here we don't even have it working, right? So what's going on here? Z and S should definitely not be allowed. Okay, S1, S2. So let me make sure I have D1 and D2 correctly here. S1, D1, D1, S2, D2, D2. For word in S1, if word not in S2, res it append word. Print S1, S2. Okay. Whoa. Okay. Yeah, S1 is empty, rightfully so. ZSEJT. Ah. I remove all the duplicates, even though I don't want to remove all the duplicates. Ooh, actually, this is even simpler than I thought. Okay, well, actually, yeah, now I just realized how to do this efficiently. Okay, this is great. Not only efficiently, but how to do this correctly. Okay, S1 and S2, so we have to do the splitting, that's for sure. For word in S1, D1 of word equals this, sure. Now we have a counter. Then for word in S1, we want if D1 of word is equal to 1 and word not in S2. So these should be sets. S1 comma S2 equals set of S1, set of S2. So now we make these into sets. Or in fact, I can just say not in D2. Okay, there we go. And then same thing here. If D2 of word is equal to 1 and word not in D1, res it append word. Now let's run this. Okay, and there we go, and that works. Okay, bada bing, bada boom. There we go. Okay, 60%. Okay, but we're at 35 milliseconds. Yeah, okay, this is 30 milliseconds and so on. So we're right there. But like, okay, could we do this any faster? So the splitting we have to do, and we could make them into sets. But if we make them into sets, then you get rid of non-unique words that you need to be able to filter out. So you can't make them into sets yet. So the very first thing we do is build a counter for the number of times each word happens. Okay, so if we could make something more efficient, it would be the fact that like I'm looping over S1 twice and looping over S2 twice. Would there be a way to do this where I loop over each one only once? Where it's like right now I'm building, probably not, right? Because, or at least like you need to build one before you can do the other, and because you have to build one, you have to at least loop over one of them twice. Maybe I can get away with like getting rid of one of these for loops and not two of them. Yeah, I can't put this in here because it's like it could be the very first time I see it. I mean, yeah, I mean, plus this is well, complexity wise, right? Just because I do this twice and this twice, it's still O of 2n, right? So it's like, it's still O of n and so on. We can resubmit this, but like we're just a few milliseconds short and so on. And like, this is just as efficient as you can get, right? Like I might be like 4 milliseconds slower than like, maybe like someone made it in like just 2 for loops instead of 4 and so on. But at the end of the day, it's like if you take n to be the max of the lengths of S1 and S2, then the overall time complexity is just O of n, right? So it's as efficient as you can possibly make it. But otherwise, yeah, that's pretty much it for this video. As always, I do a quick summary of how I was able to solve the problem for each one of my videos. So in this case, all I did is essentially, we have these two sentences, right? And we want to find the list of all uncommon words, where a word is uncommon if it appears in exactly one of the sentences. And in that sentence that it appears in, it does not occur more than once, right? So for example, the word this is not uncommon because it happens in the word S2. Apple, the same thing. But the word sour is definitely uncommon because it appears only once inside of all of S2 and it does not appear inside of S1. So that's why sour is part of the output. And then same thing with sweet. And then in this case, for example, apple, apple, you have apple. This is the very first thing I didn't realize. This does not count because even though it does not occur in S2, it occurs more than once inside of S1. Therefore, it is not allowed. And so the way I did this is the very first thing is I split S1 and S2 by their spaces, right? So I take a string like this and I create it into a list. So like this would become essentially this apple is Sweet. And then same thing for S2. I essentially turn it into a list of all the words by splitting it out across the spaces. And then essentially from that point onwards, it's like, okay, for each word in S1, let's count the number of times it occurs, right? And the way we do this is we just create a dictionary and we D1 for S1 and D2 for S2, where it's like D1 of word will equal to the number of times that that word happens in S1. And the way I do it is like literally just for every word in S1, add 1 to the word for inside of D1. And if it doesn't exist, the way I do this is like I get the value of D1. And if it doesn't exist in D1 yet, then the base value of 0. So the very first time I see it, this will be 0 plus 1 is equal to 1, which is good because that's just the first time I saw it. So I've seen it a total of 1 times, right? Otherwise, it'll be whatever values in there plus 1. So I add 1 to the number of times I've seen that word. So I do that for both S1 and S2. So essentially, I have a mapping from every word in S1 to the number of times it happens in S1, as well as the number of words that happen to S2 and the number of times it occurs inside of S2. And then all I do is essentially like, okay, let's loop over all the words in S1 again. Actually, could this be an optimization where it's like instead of S1, I do D1 and this I do D2? Right, because this would be only unique words. So this is actually a tiny enhancement. That should make me go faster. Yeah, there we go, 83%. Okay, very nice, very nice. Okay, otherwise, all I do is I say like, hey, okay, we now have the count of, yeah, okay. Where we essentially, so now we essentially have a mapping of, for both S1 and S2, every word in S1 to the number of times it occurs in S1, and same thing for S2. For every word in S2, we have a mapping from that word to the number of times that word happens in S2, right? And then essentially all I do is I say, hey, okay, for every unique word in, well, not necessarily unique. This just saves on space and so on. So the idea is that like inside of S1, I might have apple, but if I make a dictionary of the word maps, I'll just have apple happen once as a key with a value of 2, right? That way it's like iterating over all the quote unquote like actual unique values inside of S1 instead of looping over it in case it is repeated many times and so on. So I just save on computation a little bit that way. But otherwise, essentially, I just loop over all the words in S1, all the words uniquely. And for each of them, I say like, okay, if the frequency of that word is 1, i.e. it is legitimately unique, like it appears exactly once inside of that sentence, and that word is not in the other dictionary, right? So D2, right? So if it is not inside the second sentence and it appears exactly once, right? Equal 1 inside of my current sentence, then I append this to my result, right? And then I do the same thing for D2. D2 representing the map of words to frequency inside of the sentence S2. I say for each word in there, I say if the frequency is exactly once and it does not occur in the other sentence, then I append that to my result, and then I just return result, and bada bing, bada boom, that is it for the problem. So I hope that explanation makes sense, and yeah, that's pretty much it. In case you want to do something similar to what I do, the extension that I use is called LeetSync. Essentially what these guys do is whenever you submit a problem here on LeetCode, they'll automatically submit a copy of your solution onto your GitHub repository. So let me just showcase that really quickly. If I type in uncommon words from 2 sentences, you'll see that I committed something 2 minutes ago, even though I was not on GitHub 2 minutes ago. And essentially the very first time you submit the problem, they'll put a copy of the description as a readme.md file, as well as every time you resubmit the solution, it'll have you the time it took to run the problem, a copy of your solution here, and bada bing, bada boom. Just very, very useful in case you want to do something similar to what I do. But just because I recommend this extension, by no means does this mean you have to blindly trust this extension yourself. Always do your own due diligence before you trust a random guy like me on the internet. But otherwise, that's pretty much it for this video. If you did find it useful or enjoyable, I would highly appreciate if you left a like or a comment. If you do leave a comment, I promise to respond to every single one of your comments. Whether it's LeetCode related or not, feel free to talk about your hobbies if that's of your interest. Otherwise, of course, you want to talk about LeetCode, I'm more than happy to talk about that with every single one of you guys, whether it's because you want to give advice to me or the other way around, or you just want to share about how your LeetCode journey is going and so on. I'd love talking to each and every one of you. And if you want to talk about something else that's not even LeetCode related, even if it's not even computer science related or technology related, absolutely feel free. I'd love talking and chatting with every single one of you guys. But otherwise, that's pretty much it for this video, and I'll just catch you in the next one. So until then, ciao, ciao, my friend. Bye-bye.